Hi everybody, Zach here, and welcome to the third lesson in the C++ series. We'll be covering the code we used in the first and second lesson to understand how it's set up. I think that is important at this point to understand and to consolidate the knowledge from this lesson and the last lesson. I'm going to present you two challenges. The first of which is something you should be able to tackle right off the bat. The second one, you'll need to do a bit of research. Like I said, it's a challenge. I know I decided to cover other aspects on variables. I think it's better to do these two parts first, and we'll cover the other aspects about variables, so global versus local, for example, in next week's video. That said, fire up Visual Studio, and I'll see you on the other side. So, per the intro slide, as I said, we'll be going over our two files from the last videos. So the first video, we created our hello world file, and in our second video, we created a file with some different variables in it. A lot of the stuff we'll be talking about will kind of repeat between the two. So let's start with the simpler of the two to make sure we have a clear understanding of what's going on here. So, of course, we already know what a comment is. At least I'm hoping we do. And as we saw, there's a couple ways to do that. We can use the stroke asterisk approach, or just use that double stroke approach there. At the top of our C++ file, we have this first include here. You see a .h file. What you're looking at is what's known as a header file. And this is the reason why we are doing this first before we continue with variables. Because when I bring up the next part on variables, I want to relate it to headers and construction and initialization of our variables. And we can actually even see our header file over here. So if you look at your project, you'll see, we have our header right inside of there. We can open it up. So this is our header. We have some useful information in here about what it does, solution for Windows to add and manage files. You just have a lot of different things in here that are just useful. We'll use this header file or other header files to construct things when we move over into, say, programming in Unreal, which is another reason why we're doing this before we can do with variables, is we'll declare and potentially initialize some of the variables in here. So going back from there, so that's our header file. And this is particularly our pre-compiler header file. So we actually won't be using this one too much. The pre-compiler header file does exactly what it says. It's for pre-compiling. We might want to do things after we compile on init or begin play. The header file will take care of for us that are going to be separate. And they'll have header files that are created for us mostly by Unreal itself. This here is probably one of the most important sort of includes you'll see. So just to quickly break it down for both of these, what include is saying is it means, when you compile this file, bring the information from whatever the source is over. So bring the information from this pre-compiler header over, and this one is a library. It's one of the most commonly used libraries. It allows for us to put inputs into the console. So when a person types in something, this will register them typing. It also allows for us to put information out onto the console screen for the user to see and to understand. Now, we could do something a bit different. I'm just going to double check we did it in this one. We could use this call here using namespace std in conjunction with this include. std stands for standard, by the way, is a namespace. So we're a namespace within IOStream. So within that namespace, there are a bunch of functions related to that library. So that particular standard library, for example, has our cout and L. So these two bits down here. The reason why I typically will not use this using namespace std is, while it makes writing the code easier, I don't have to put in std : each time. It means that if I use a namespace that is, say, declared by another library as well, the system won't know which one to use. Or if I create a variable or a library with a namespace and I call it, and it has this std in it as well, it's going to confuse the system. I find it's, or if I just want to actually use std for something, it's going to create confusion for the system. So I find it's better, one, not to use a namespace to avoid potential conflicts with how things are inputted, and two, because when I look here, I kind of know where this is coming from. I mean, this isn't the best Intella, can't remember what it's called, the sort of predictive to tell you stuff. It just is a good reminder so I can know that, hey, it's coming from a standard library, and most likely my standard library is going to be my IO stream. Now, in console functions, for anyone old enough like me, and I hate saying that, to remember when consoles were required, a console needs to have that return. So if it doesn't return 0, it's saying something's gone wrong and there's an error. So it's expecting to see this at the end. It's a throwback to when we used command lines in console code, for anyone remembering the old MS-DOS days. Now, this line here, this std, just stands for standard, as I already mentioned. So it's calling the library, the standard function library, from the IO stream. It then says, after these double colons, what you want. So you want to get from that IO stream. As you can see, when you run the mouse over the cout, you can see it is standard IO stream there, standard cout. C standing for console, out, kind of think about like output. So what do you want to put out? What do you want the console to display? That black box we get when we run this. So let me make sure I have the correct project active. And that correct project actually is in here. So I'm just going to very quickly do this as my primary one. And I can never remember where it is in this because I've been using CodeLight and Visual Studio Code instead of, there we go, instead of Visual Studio itself. And we have our pre-compiler header in there, by the way, as well. We also have our header files. So let's just quickly run that so you can see it again. Oop, not that. Go to build solution. It'll quickly compile it. It'll put up a display for the console. Thank you. And now let's debug it. And there's our console with the information coming up. And you can see we get a whole bunch of information for debugging down there. We'll worry about this stuff later on. So in here, we have the hello world. You'll notice there's a space right between the hello world and the next little bit there. That space is coming from this end L, which stands for end line. Again, that's being called by this IO stream. So we already had that verbose explanation here in the comments. And again, as I said, we want to return 0. Now, these brackets are just saying what's inside this function. And in fact, actually, you can have things inside of this main as well. So it should know what to expect in here. You don't typically need that stuff. So if you go back to this one, again, we have the same IO stream. We have another pre-compiler header that will be unique to this file, or to this project. So remember, each one of these, is a project. So this is my workspace. This is a project. This is another project. I'm just going to set this one as my main project. So in it, again, it has its own pre-compile header. It has its own IO stream. I declared we're using namespace just so I didn't have to type in the std here. So you can see there is no std : no std : here. So remember, we have multiple ways of declaring things. So as you can see, we have our commented out earlier versions of this where we have, print the size of some primitive variables, which I have spelled print wrong in there. I'm not sure what a print is, but okay. And all it's saying is, on the console, display the size of a boolean. We put a space between there and the colon in the end, because if we didn't, this would print right next to that colon. So we have to remember to include these spaces. And then we used a command that comes from standard C code. And you can find a list of these sort of items all over the internet. There's other ones we could have included. We could have even included ones that told us, other information about what a bool, what a bool is, including ones that will give us the minimum and maximum range. So remember that table from last time where I said I kind of fudged the numbers. If you want an accurate version of that, I challenge you guys to look up what library you're going to need. There's your hint. You're going to need a library that we haven't declared up here. And yes, it will be an include that you're going to put up in this area. It'll be directly on line 10 if you have the same number of spaces, or right after the IO stream, that will allow you to get certain math functions. And you can use the same approach and, do the range of a boolean is space, your carets. Use that math function. I'm not going to tell you which one it is. You'll have to find it. Declare what you are looking for. So remember, primitive variable, and then have another, caret, and then a quote, space, and the maximum is, and the same idea repeats. Now, that was just a little bit of a challenge for you guys to do if you want to see, what the actual ranges of these are. It's also a good challenge to practice the coding, or the art of coding. And yes, I call it an art, because everyone will have a different approach. The science of coding is in the logic, and in understanding the logic, and in understanding the setup. But when you go to write code, think about it. Find a way to conceptualize that makes sense for you. So the way I tend to think about coding, for example, I tend to think about it the same way I do about writing. And having been a published writer for a little bit, mostly research and academic work, nothing that you guys would find interesting, I think of it as there are certain rules that you have to obey. There are grammar rules, spelling rules, all that stuff. You learn that, and the rest of the writing process is, even with academic work, is an art form. You're trying to convey ideas. You're trying to explain things, and that is an idiosyncratic approach. So coding really does, as you get farther and further into it, and start dealing with more complex stuff, become rather idiosyncratic. So just find a way to conceptualize it. It will make it a little bit easier to wrap your head around. So as I said, I'll talk about local versus global variables. Again, that will be actually in next week's video, just because I wanted to break down this code a bit. And we have different ways to initialize, as we've seen. We can, just declare it and then initialize it later on using this sort of approach. So these two go well together. We could declare and initialize at the same time. And in fact, we'll talk about what a constructor is when we get to the next video, sorry, not the next video, actually it might be the next video or the video after. Because when we start combining these ideas of declaring and initialization and global variables versus local variables, as well as constructors, we're really going to need to start looking at some of these header files we might want to include, where these variables are set up before they come into the C++ file. We also then have a different method from C++ of setting our variables using a C++ 11 constructor. All the 11 means is the iteration of C++. There's a really good Wikipedia article. I feel really disgusting using Wikipedia as a reference, but it is actually fairly good in terms of certain tech things that lists the different forms of C++. Anything post C++ 11, or C++ 11 and post, that is considered modern C++. So any one of these approaches, declaring and then initializing, using a C++ constructor, or using a C++ 11 constructor, will work. By the way, these spaces, that Visual Studio has added in on either side of the number are actually not needed. Do remember you do need these single quotes around our character. And again, just like up here, remember we had to include that space. You already know what the cout is, you already know what the endl is. And you can, as I mentioned, also declare and initialize variables on the fly, so to speak. So we've declared two variables and initialized them here using C++11 constructors. We then have this one variable down here, however, which hasn't been defined. We define it on the fly based on these. Now, what we could have in here instead is some code asking for a person to input a value. And in fact, what we're going to do is we're going to do just that. We are going to, just very quickly to show you how this works, we're going to remove these two items. What we'll do is we're going to create a new set of command in here, just for a little bit of practice. Sorry about the little bit of jump there. My computer decided to act a bit weird, and I just had to quickly reset the camera. I'm actually going to undo what I did earlier. We have an error, mostly because there's two undefined things there. But instead of doing it this way, we're just going to comment this all out. Sorry, I just want to make sure I'm highlighting correctly. And we're going to talk about a different way to declare these variables, and makes a little bit more sense. Sorry, I'm not sure why that didn't comment it out. Here we go. Instead, what we're going to do is we're going to declare these differently. What we're going to do to declare them, we're actually going to declare them as this goes. So what I'm going to do, the first thing I want to do is I want to declare my first variable. So actually, I'm going to make a comment about what I'm doing here. And we're going to do dynamic declaration and input. Stroke initialization. I'm still probably spelling that wrong. And input from user of data. So the first thing I'm going to do is I'm going to declare my width local again. Actually, sorry, not width local. I did length local at the top there, sorry. You could do it either way, it doesn't really matter. And what I'm going to do is I actually am going to use a C++11 constructor. I'm just going to declare it as 0, so there is some value in there. And then I am going to prompt the user for a response. And I'm going to use a bit of code as well. I'm going to use, instead of end line, I'm going to use something a little bit different. And I'll show you that as we go as well. So remember, I don't need the standard space because up here we're already saying we're using the standard naming space. So I'm going to do cout. And then what I'm going to put out, so it's telling which way to look over here. So this information is going into cout. That's how I tend to think about it. I think the arrows are pointing into cout. So anything on this other side of these arrows is going into the output for the console, if that makes sense. What I'm going to do is, please, proper grammar, enter the length of the object you want the area of. And again, notice I put a colon and a space, so you don't really need to do that. And we're at the end of the line. We're not going to use an end line because we actually are going to want something. We're just going to put a colon there. And then we're going to type in C as in console, and we want information coming in. And what we want to come in is this length local. Again, that null terminator, that colon at the end, otherwise it won't work. So what's happening is we're declaring a variable, we're initializing it as a value of 0, and what we'll do, since we're working in meters, is just put m there so I know it's meters, just to be, again, a little bit pedantic and we get used to doing this. Sorry, as an American, I'm not sure if m is capitalized now. I'm going to do lowercase. I just don't like the look of that capital M for a minute for some reason. So we are then sending out to the console, or putting this information, this string, out to the console. We are then taking information in from the console. What we want to take in is this length local. To make my life a bit easier, I'm going to declare my new variable, which will be int, and the int will will be get a int for the width now, and that'll be width local. Again, I'll use a C++11 constructor approach. So we now have declared and initialized our width local, and I'm just going to copy both of these now and paste them in. Going to then copy my width local and just paste it over that, and then we'll do width here. So now we've got in both pieces of information in. I'm going to go down a line, and I'm going to declare this variable again. I'm going to first do that same sort of constructor, and it will be area local. Now, I could actually just use the same exact line here instead, but I like to be consistent in my declarations. It's just a habit I have. You could, as I said, just have done this line instead. You don't, and you shouldn't, always follow these exactly. You should use the approaches that make sense for you. And right now, if you don't know what approach makes sense, you follow along. Experiment, experiment, experiment. I cannot stress that enough. That is the best way to learn this material. Now, the next thing I'm going to do is I'm just going to actually be lazy, and I'm going to copy everything but the int from up here. The other reason why you could have just put an int and that up there, and then declare then initialize it, or sorry, not initialize it, but then change on the fly what the value is. And then I'm going to be, again, a bit lazy. I'm just going to copy this again, because everything there is the same. I'm skipping the end out, because I said I was going to do something a bit different. And I'm going to do a stroke n, which is, again, it says means go to a new line. So let's save this. Let's build it. Hopefully this should take relatively a short amount of time. And I am missing a colon there. And where else am I missing a colon? Oh, it's the same colon that's missing. That's fine. This should now compile, I hope. There we go, it's compiled. Let's debug it. So it wants me to enter something. And I forgot to comment out the top part earlier. Sorry about that. So you can see I have the debugger working, so we can see how much memory is being used. That does not seem like it should be using 4 gigabytes of memory, but oh, that's 4 megabytes. Sorry. An earlier debug I did was using 4 gigabytes, so I just automatically assumed. So I'm just going to put in a number here. I'm going to put 23, and I'm going to put 10 in, because I should know it's 230. So then we have the area of the trials room is 230. I, however, messed part of this up. As you saw, it displayed that, that bit instead. So what have I done wrong there? Well, what I've done wrong is wrong slash, actually. That's all. We will just do that. We will build solution. You don't need that extra space. I just put it in so I could see what stroke I had used. Unfortunately, my eyesight is somewhat meh. Let's just leave it at that. Again, I'll do 230. Actually, yeah, no, we'll do 230. I'll show you something else in a second. And there you go. We see that space now. And we have all our debug information. I want to show you one more thing with this real quick. What I'm going to do again is I'm going to go to debug. I'm going to start debugging. And I'm going to type in 23 and 10. And you're going to see that it jumps straight to the end. This space between the 23 and 10 kind of tells it, oh, I've already received this input. It's looking when you do this input, when you do these inputs. I'm just going to move this over here so we can look at these side by side. So we declare both these variables as integers. Integers do not have spaces in them. So when it sees, hey, enter this, enter length, it looks for the length of the number, or sorry, the numbers until it hits a space or until you hit return. So it sees 2 and 3, space. It then continues to see numbers, but it isn't going into this length anymore. It's going, oh, I've hit the end of it. And it jumps down to the next time we're declaring something, or next time we're declaring something, which is down here. Or sorry, not declaring, where we're setting a value. And it sees there's two more numbers over here, and then a return. And it puts those two numbers in, and then it just skips down to this. So just be mindful, and there are ways to address that actually. There are ways we can control what the user puts in. What I want you to do, based on this material, is I want you to create a very simple game. The first thing I want you to do, I'm going to tell you the end project. I'm just going to type this out as a comment so you can have it on screen. Is I want you to create a game where it will guess at either someone's favorite number, or you have to guess the machine's favorite number or favorite color. Try both. And so the end product will be, guessing game, using console commands. Everything we've done so far, you should be able to do it, except for you're going to need to look up something to get the final version of this right. And I want to see if you guys can kind of tackle it on your own, using the internet to look up some resources. What I want you to do for this guessing game, in terms of color and number, is I want you to have a user guesses at computer's favorite number and or color. And the first project in this, the first sort of iteration 1, is one game one attempt by the user to guess. The user is automatically told that they are right. So, hey, take a guess what my favorite number is. And then the challenge to this, in this iteration, is, if you say my favorite number is, so enter, or color even, guess my favorite color, so that's going to be a little more of a challenge. Guess my favorite color. So this is the computer on the console, and the user types in, say, green. I would also say give them a list of options so they know how to enter it. And the computer will go, OMG, you guessed right. But that's pretty simple and kind of obvious what's happening. OMG, OMG, you're right. Green is my favorite color. Iteration 2 of this, I want you to allow for multiple guesses. And try this with the number instead of the color, because you're going to need some statements, like, some particular statements we've talked about in my other tutorial series that we haven't used here. At what number the computer is thinking of. Oh, and then I'm just going back up here. The program should end at this point. End program. Sorry, I'm not going to spell it the British way or French way. So, what number is the computer thinking of? And so the challenge is this iteration, this challenge. Actually, it shouldn't be iteration, it should be challenge 1 and challenge 2, I guess. So this challenge will allow for multiple guesses. So, and I'm also going to make another note up here just to make clear. You will not need anything more than what we've covered already, except you'll need strings instead of char, or characters. So this will allow for multiple guesses. This will require you to look up some code. I want you to think about what logic you would need. And it's fairly simple logic. So what do you need to know if the person has guessed right or wrong? And then based on the response, if right, say they are right, and close out the console, or end program. As you know, it doesn't close out with the debugger activated right now. If wrong, ask them to guess again. Now, this might seem really, really stupid. And I'm like, why are you having us do this? Again, best way to learn this is to do, practice at things. But if you want to think about something, if you want to think about, you ask the user to input some data and the data isn't valid, this is going to be very similar to what you're doing there. So if you ask someone to put a birth date in, for example, enter your birth date, and you want it in a numeric form. So you want it to be, month, they're born in, say, January, actually, what's today's date? They're born on April 9th. Yes, I am recording this the day this is going up, which is probably... So, what is today's date? Today is April the 2nd. So instead of saying, 0 to April, you want them to say 02/04/2019, and they put in April instead of 04, it's not valid. Or they put in, some random quote, they put lorem ipsum in or something really random, and it doesn't actually, match what you expect. This code sort of here will be the same logic and mostly the same code they would use for a content check, potentially. Alright, that said, next week we will go over our globals and local variables. We'll go over assigned and unsigned, and we'll do so hopefully in relation to thinking about it in terms of our headers, not the pre-compiler header, but other headers we might include. That all said, I will also show you different ways to do this, and I'll show you different code we can do. So next week's video might be a little bit longer, or it might be split into 2 parts, but both released on Tuesday. That said, again, because this series is meant to be a build-up to getting ready to program in, getting ready to build in C++, with regards to using it in Unreal, please leave some notifications below or comments below about what you'd like to see in this series, what works for you, what doesn't work for you. I know this is a very challenging concept, and right now we're doing the boring stuff, but in order to tackle the stuff we're going to do in Unreal, we need to get through this boring stuff and need to make sure we understand the base concepts. That said, if you like this video, drop a like below. And I hope to see you either in the RTS tutorial series or in the next video in the C++ series. And as always, I hope that you have a wonderful day.